Hello. Thank you all for coming to my talk, for virtually attending from your hopefully very comfortable locations. Today, I'm going to be doing a deep dive into one very, I don't know, so I don't want to call it small, one very specific aspect of game audio programming, which is the music. So let's first do just a little bit about me. I've been in games since 2002. I've owned the audio engine just about every company I've ever worked at, either for the entire studio or for just the game that I was working on. And over the years, I have shipped lots and lots of games. As you said, everything slot machines, AAA titles. I've worked on indies, tech demos, lots of really neat stuff. I'm also the author and editor of 3 books on game audio programming, the Game Audio Programming Principles and Practices series. These are books that are GEMS-style articles from many of the top game audio programmers in the industry. They are very valuable resources. I've learned a lot from editing them and from writing them. There are topics ranging from low-level mixing, game integration, music, all of it. You can get them from the publisher, CRC Press. You can get them from your local independent bookstore. They will be able to order them for you, or from wherever fine books are sold. So today, let's talk about what we're going to talk about. So it's just a quick introduction to game audio programming, and then we'll dive into music, basics, some advanced features, dynamic music, meta tasks, and some more stuff. So let's dive right into what game audio programming is. So my definition is that I'm working with sound designers to create the most awesome aural experience ever. Now, there's a couple of phrases here that I want to highlight, which is, number one is working with sound designers. It's very important that, this is not in a vacuum, that as I do this, the features and the functionality that I'm implementing are targeted at the sound designers. They're the customers of everything that I do. And the other piece of this is the awesome aural experience. And it's important that this is not most realistic. This is saying nothing about anything other than whether it is awesome. And so that's kind of the razor. That's the metric that we use to decide whether or not a thing should be implemented. It's that, does it help the sound be awesome? So that's cool, but it doesn't really explain what game audio programmers do all day. Like what do I, when I'm doing my game audio programming part of my job, what am I doing? Well, that depends on what kind of game audio programmer I am. There are lots of kinds. Here's a few. Technical sound designers tend to be people who come from a sound design background, and they can both author the sounds, and they can also create hooks, usually do some feature prototyping, may actually be able to dive in and implement some features. Kind of at the bottom end, there'll actually be, some studios do have their own mixers, their own libraries that they're using to actually implement DSPs, do their own mixing, do all of that. There are audio tools programmers, there's all kinds of things. I tend to live right in the middle, where I am maintaining kind of that layer that communicates between our middleware and our the tools and the rest of the game, and implementing the tools that the sound designers use day in, day out to author and integrate the sounds. So what does that mean? What am I actually doing there? I am setting up hooks into the game to trigger sounds. I have to understand these sound design tools that they're using at a very deep level, because sometimes they'll say, I want to do this crazy thing. And I have to sit and say, okay, in order to do that crazy thing, you can hook this feature with this other thing that maybe you didn't know about, and now you can do that. So kind of having to teach the sound designers how to use how to use some of the game tools. Implementing custom effects, maintaining all the logic that connects the audio engine with the game, all kinds of really cool stuff. And the number one bug, if you walk up to just about any audio programmer in the entire games industry and you ask them, what's the number one bug that you have to fix? And that is, why are my sounds not playing? That's easily the number one bug. And it's always a different reason. Like, this is the exciting thing. I've been doing this for 18 years now, game audio programming. And every game project, I learn a new way for sounds not to play when they should be. So it is just the bug that will never disappear. But the one thing that you notice is not on this list, I'm generally not pushing samples into the device driver. I'm not sitting at that level that's at the callback coming from the device driver or from the Wasapi or Core Audio or whatever, and giving it a buffer of data. I'm hardly ever doing that kind of stuff. Because in general, in the game world, middleware is king. We use FMOD Studio or Audio Kinetic Wise are the two popular products in kind of the US and Europe. If you're in Asian market, Japan, China, they tend to use CRI ADX2. So what are these tools? FMOD Studio is, and so all of these tools provide kind of a low-level API that you can use to access, to load and playback sounds, and then a sound designer tool. So let's take a look. Here's FMOD Studio. This particular track is a music event that has a kind of resting intensity and a low, medium, and high intensity tracks. And there is a single parameter that the game can send that says, how intense should it be right now? The track reacts by waiting until the next beat and then doing a transition, which includes a stinger or something like that, some sort of transition timeline to transition to the next, the desired intensity. And then when you finish the track, it has an automatic, again, it waits till the next beat and then goes and has a tail at the end. All this completely automatic. The only thing the game has to do is pass in the music intensity parameter. This is Audio Kinetic Wise. This is a glass bottle impact event that has different sounds that it uses based on how hard the impact was, whether it's bouncing or whether it shatters. And then it also applies an effect, a low pass filter, a pitch, and a volume adjustment based on the intensity of the impact or the force of the impact. This is CRI ADX2. I believe this is a music event with multiple tracks and some effects. I'm less familiar with this tool. So this is the fundamental. This is kind of a given. All of these tools, this way of interacting, this is the given. This is the baseline that we're starting with when we start to talk about game music. So let's talk about game music. Game music is there to set the mood. It's there to be part of the ambiance. It gives you a flavor, makes you feel as though you're there. And usually it is part of the background. So it's not a thing that is upfront in your face. Every once in a while it is. For example, if you're playing Rock Band or Guitar Hero, those kinds of games, obviously the music is the gameplay, in which case it needs to be the foreground. But in general, most games, it's part of the background. And the real tension with authoring the music, with composing it, is that the music should be awesome, it should be memorable, but it should be unremarkable. That is to say, if you're playing the game and you're noticing the music and you're listening to the music, then you've probably done something wrong because you should be paying attention to the game. The music should be kind of feeding into the game and making you more immersed in the game and the gameplay rather than bringing you out and making you notice itself. So this is the tension. Is like you want to have awesome, cool music that is also unremarkable. So this is a challenge for composers, for game composers. Let's dive into the basics first of music. So the basics are some of the choices that you have to make, how to hook up, how to author your music. Let's talk about hookup first. So the simplest way to hook up your music is kind of by level, by area in your game. Level 1 gets music 1, level 2 gets music 2, level 3 gets music 3. That's simple, obvious, but it functions for many games. I mean, this is obviously Super Mario Brothers, which is ancient, but even modern games will follow this pattern. You can also do, if you have a more complex arrangement, by area within a level. So for example, if you have, this is your game map of the world that you're in, maybe in section 4 there, it's a different room, so you'll have a different music there. Maybe section 1 is where the boss is, and so you're gonna have different music there for the boss, and maybe in 3 you're kind of getting it close to the boss, So maybe we'll start the music there and kind of bring up the tension as you get closer to level 1. So again, if you do this, you'll have a box or a shape that is defined in the world that when you cross into that, you'll crossfade into the new music. So these are the kinds of choices you have to make. Where's your music hooked up? Where does it come from? You have other choices to make. For example, are you going to make your music 2D? So it's kind of ambient, just part of the environment or part of just the sound of being there. Or is it going to be a 3D sound, like a jukebox, where there's a thing in the world that is making the music? And again, part of this baseline, if you're using FMOD, Wise, or any of these other things, they will have a 3D panner. So as your character, your viewpoint pans left, right, up, down, or moves around in the world, the sound will actually pan and attenuate correctly, such that it fills whatever your speaker configuration is, it will fill it correctly. The other thing you can do in this space is you can make a hybrid where as you get close to the sound source, it becomes 3D, and when you get further and further away, it becomes more and more 2D. And this is, by the way, completely automatic. You don't have to write any code to do this kind of 3D thing. You can set all of this up directly in FMOD or Wise or any of these tools. Other choices you have to make. Are you going to make your music stereo, or are you going to make it multi-track surround? Now, I've got here a panner that is on the right, is a 7.1.4 panner. So if you have a meaningful 13-channel mix for your music, we can play it back, and if you are playing it back on a stereo system, it will downmix cleanly to stereo. Excuse me. Most games will just be using stereo. Most games, the music is just stereo, it's placed left and right, and you're done. However, again, if you have a meaningful reason to do surround sound, any mix, I picked 7.1.4 because it's extreme, but if you want to do a 5.1 mix, again, that will downmix very cleanly. But there are trade-offs. If you have a 6-channel mix that is 3 times bigger, it's 3 times more disk access, it's 3 times, it's more expensive, and so you have to be aware of that. Other things to hook up. You got your title screen. Most games these days have a kind of press start to begin, and you want some exciting action music there. You got your main menu, which is usually like, do you want to do single player, multiplayer? How do you want to play? That might have a different music track than a title screen. Your character create and select could have its own stuff. On Torchlight 3, the game we just launched, we have a whole like cinematic sequence as part of your character creation, and so that has its own music. Cinematics, another thing that is will need its own music and its own hookup. So a lot of the basics are just around making decisions about how you're authoring the music and where and how you're hooking it up. So let's talk a little bit, let's dive a little bit more into some advanced features. And the advanced feature I want to talk about is dynamic music. So dynamic music is about reacting to the game. It's about the music reflecting the music's intensity reflecting the game's intensity. So the game has to communicate to the music how intense it should be, but the the ideal situation is if the music is actually proactive to the game's intensity. So that means that rather than, oh, you've entered combat, let me turn on the combat music, it's more, you're about to enter combat, let me ramp up the tension so that when you're in combat, we have ramped up, you're already in the combat music. There's lots of ways to do this. Each game is going to have a different way of accomplishing this because each game is different. But I want to do a deep dive case study on Torchlight 3, again, the game I just launched about a month and a half ago. Available on Steam, Xbox, PlayStation, and Switch. So we were lucky enough on Torchlight 3 to have a composer on staff from day one. We have Matt Ullman, who's working with us. He did the music for Diablo, Diablo 2, Torchlight, Torchlight 2, Hob, and I think some other stuff. So we got together at the very beginning of the project, and we sat down in front of the whiteboard and wrote out a plan for how we were going to do the music. And this is what we came up with. This is a fairly traditional dynamic music setup where you have kind of three tracks, three stereo tracks that are sample accurate. That is to say, they have the exact same number of samples. And the idea is that you can have a loop region in FMOD, and then which is our middleware, FMOD Studio. We can have this loop region, and then as the game's intensity changes, we can fade the appropriate track up and down, basically crossfade the tracks. And so we decided on this. We said, this is what we're going to do. It's going to be awesome. And we never actually implemented this. 0 times in our project's history did this ever actually happen. Instead, we ended up with this. So this is our Goblin Forest daytime music track. You see it's got tons of these things. It's got this big long loop region. It's got a ton of these tracks that you see the music, the tempo is changing. That's because this was a live orchestral recording, part of this was. And so as the conductor kind of adjusted his tempo, the orchestra adjusted with him, and they kind of wanted to make sure that we're doing things on the beat, so we had to get the tempo markings in the correct locations. So there's lots of elements here, lots of little short stingers, lots of short musical elements that are randomized. They'll pick from among a variation. And I'm even lying that this is our music track because this is only the top half. Here's the bottom half of our Goblin Forest daytime track. At this point, I'm going to do a live demo of this track playing. So here is, let's just take a look at it first. You see, this is the timeline in FMOD Studio. There's nothing on the timeline here. That's because everything is on the time of day. So we've got our this is our Goblin Forest music that references the Goblin Forest day and night track. And so the game passes a parameter saying whether it's day or night right now. So here right now we're at daytime, here's the night track. There's also an intensity parameter that passes through to the day and night tracks, and which at high intensity actually applies a snapshot of it to the game mix that that is clicking the wrong buttons. It applies a snapshot to the game mix that that changes how the game sounds. But let's go ahead and play this. And so we'll start and we'll get a fade in. Now I'm lowering the volume so I can talk. And now we'll say that you run into a few monsters, just a few of them. So we're going to upgrade to medium intensity. More of that action. You're hearing a little bit more of this action music. Now let's say you run into even more monsters. You're in heavy combat. So this is now, while you're in this combat, time changes from day to night. Now, as you're in this combat, you've killed a lot of the monsters, so we start to fade down our intensity. Now you've finally killed all of the monsters, so we go back down to idle intensity. And then we get a fade out in the end. So again, this is all built in, right? So we have our music tracks, 10 to 44 individual tracks in each event. They support a day-night cycle, and they support up to these 3 intensity levels. Now, most of this, as I said, is built in. Like, I didn't have to do any programming to hook this up, I just had to help my sound, the Matt figure out where these, how to hook some of this stuff up. But the thing that we did have to do was actually send these intensity levels to the game. And that's what I want to focus on, because that's where the game hooks into the music. So I sat down and I worked with my sound designer and said, okay, we're going to do dynamic music. I'll just do a first pass on something and we'll talk about it. So here's what I came up with. We'll find all the monsters in the radius and we'll calculate what we're calling a near drama, which is kind of an inner radius, and a far drama, which is an outer radius. And what I mean by drama, each monster in the game is assigned a drama value, which the game uses to create drama, it'll spawn monsters when it decides, okay, I need to be at a high drama, I need to be high intensity, and we should be more actiony, so I'm going to spawn monsters. And it decides how many and which monsters to spawn based on this drama calculation of like how many monsters are around you. Oh, you need more drama, so I'm going to spawn more monsters close to you. So we used the same value for the music. So we said, well, we'll just calculate the drama of the nearby monsters and the far monsters. And then what we do is we have these values. The low drama is we look at the nearby monsters, and if the near drama is above a particular value, then we would upgrade the music to medium intensity. And then we had what was called a medium drama, where if we look at the far drama value of the outer radius, and if it's above a particular value, then we would upgrade the intensity from low to medium or from medium to high. The idea there is if you've got monsters close by, then that's low, then that's at least medium intensity. If you've got close by and far away monsters, then that's going to be high intensity. But if you've just got monsters kind of around the edge, then that's still medium intensity. So that was kind of what that was intended to do. The other thing we had was we looked at the player health, and we said if your player health is low, then then you want to be at medium, and if it's really low, then you want to be at high intensity. So the player health also kind of affected this, the impact, because we decided if you have low health, then it's more intense. So I implemented this, and it worked, right? The music would change intensity. It felt pretty good. Like you would wander around and fight monsters, and the music would change with you, and we were like, yeah, especially when it worked, it was great. But the thing is that even though it worked, nobody ever tweaked. I threw in some feels pretty good numbers at the beginning, and nobody ever tweaked any of these numbers. And I had to ask why. Now, I talked to my sound designer after the fact, and she says, the numbers in there were good enough. We didn't really need to tweak them. But I think it's deeper than that, because I think the system was too complex. It had too many dials, switches, knobs. It was just too hard to grok in a way that was approachable and made sense from a game perspective. So that was already a problem. But also, as much as it worked, it also didn't work, because there was some noise in there that didn't really matter. Like the player health for our game goes up and down far too quickly and far too often to be meaningful as a metric for music intensity. Like it's not helpful. It's just extra noise. You would get into situations where it's confusing. I just had this big battle. Why didn't the music get intense? Or vice versa, where it's like, there's nothing going on. Why is the action music on? And there's always a reason, but it never really made sense. The other more subtle problem here was that game balance changes would affect the music. So we talked about that drama value. That value was used by the game designers to affect how monsters spawned. And by using that same value for music intensity, all of a sudden they could decide that this monster was low drama and then change that to high drama. And all of a sudden the music would change in a way that's like, but that doesn't make sense. So it was this weird subtle thing. We did a couple things to try and fix this, but it became clear at some point that we had to start from scratch. That the system we had was too complex and it just wasn't working. So here's what I did. I sat down with my sound designer and I told her, look, take a video recording of a play session with the music muted. Then play it back with the music event playing in FMOD, and then adjust the FMOD music intensity as you see fit, and write down timestamp and music intensity and a couple of notes about the reason why it's changing. So she did this, and I sat down with her, And we said, okay, let's go through this. And so we played back the recording and we played back the music and we said, okay, here it should go up to medium intensity. And I said, okay, well, why? Why is it going to medium intensity? And she came up with a reason. And after a few of these transitions, came up with a heuristic. And I said, okay, this is the heuristic. And we'll go into what that heuristic is in just a moment. But this is the heuristic. And then I knew that we adjusted the heuristic as we talked, but I knew that I had the right heuristic when she had in her notes a change from, let's say, high to medium. I don't remember what it was exactly, but let's say high to medium. And I said, no, it should stay high here because our heuristic says this. And she looked and she said, you are right. And the notes that she had were wrong. When the heuristic was more accurate than the notes, we knew we had a winner. All right, so let's dive into what the new hotness was. What we did is, again, we found the monsters in a radius and we assigned each monster, instead of a drama value, we just assigned it a category. It was either a popcorn monster that could be killed very quickly, a standard monster that you kind of have to fight, a brute that is more scary, or a champion, which had special rules. I'll talk about champion rules in a little bit. But basically, popcorn, standard, and brute are the standard designations. And then we had values for if you have a certain number of popcorn, standard, or brute monsters, then you can upgrade to medium or high intensity. So the algorithm is basically find the monsters, count the number for each category, but also convert to all the other categories. And I'll talk about what that means in a moment. And if any conversion is over any of the limits, then we upgrade the music. And that is, the reason for that is we want the action music and the medium and high intensity action music that's where the exciting stuff is. You want people to hear that, so you want to be eager to upgrade from idle to medium or high intensity, but only to the correct one. Let's go over an example here. Let's say we've got a goblin warrior, which is popcorn, a goblin gunner, it's standard, and a goblin brute, which is a brute. And these are our values. To upgrade to medium, you have to 8 popcorns, 3 standards, or 1 brute. To upgrade to high, you need 15 popcorns, 5 standards, or 2 brutes. But we do the conversion. So here's kind of a set of examples. You can see that we take the warriors, so the popcorns, add them up, take the gunners, multiply by 3, add that to the warriors, take the brutes, multiply by 5, and add that to the total. And now we have a value that we can do the other conversions. We can take that value, that's our popcorn value, we divide it by 3 to get our standard value and remove any remainder. We divide by 5 to get the brute value, and again, remove any remainder. And you can see that, again, any of these values, any of these conversions will upgrade us to the appropriate, to the medium or the high intensity, even if the individual value would not on its own. And all we have to do is these conversions. So we do all 3 conversions and check all 3 values. The extra rules we have are about champions. So in our game, a champion is like a regular monster, but then we scale it up, we give it more hit points, we'll give it some special affixes, things like maybe it trails fire, or it shoots fireballs, or it has poison nova that it does every 5 seconds, or it explodes into 2 smaller versions of itself when it dies, or whatever. So there's a bunch of these things. And so each champion, if there's 1 champion on the screen, then you're immediately at medium intensity. If there's 2 or more champions on the screen, you're immediately in high intensity. Couple other extra rules: if you're dead or you're on the loading screen, we'll just go down to low intensity because there's nothing going on. Bosses will override with their fancy special music, which is, of course, going to be intense. All right, the last piece here for dynamic music is about time limits. And there's 2 reasons to have time limits, and 2 different kinds of time limits you want to have. The first one is, there's a couple of reasons, which is that we want to have minimum times at each intensity level. And the reason is twofold. First, you want to avoid popping, right? If you have a bunch of monsters around you, then you get up to high intensity and you kill them all in one big like nova blast, then your intensity, you don't want it to pop immediately down to low or medium intensity because you just got up to high intensity. Because the game is constantly flowing up and down in intensity, or in game intensity, the music, you want to slow that down just a little bit. So if you're at high intensity, it's okay to have some minimum time. The other reason is just you want to make sure players hear the music. If it's popping up and down and up and down, they're never going to have a chance to actually be and settle in a particular intensity. On the other side of that, you don't want to be at high intensity or at any intensity for too long to avoid ear fatigue. So we have kind of a max time at high intensity, a max time also at medium intensity. And even at the low intensity, we'll have what we call a silence timer, where we will actually turn the music entirely off if you're at low intensity for long enough. And that's, again, just avoid ear fatigue and let the ambience and the game kind of take center stage for a little bit. So that's dynamic music. And again, there's lots of ways to do this. This is just how we did it on Torchlight 3. Now I want to dive into some meta tasks. So what does it mean, meta tasks? And so for example, one meta task would be marketing, right? You've got all these cool music tracks and marketing comes to you and they're like, we want to use that in our trailers and our cinematics and our cool stuff that we're releasing, where we want to do an original soundtrack, right? An OST, and release that as a downloadable or a sellable product. So this actually happened. I went and visited my sound designer and she was in a really bad mood because she was bored and miserable doing this thing for marketing where they wanted for each music event that we had, they wanted each track broken out so that they could craft a mix from this. So what did they do? For each track, she had to solo the track in FMOD. She had to remove the loop region, which is a one-time thing, but she had to solo the track, route the output of FMOD to the input of Pro Tools, hit play and record, and then she had to listen and audit and make sure that it was all good. And then go and continue on. Like this was the thing she had to do for each and every single track for each event in the game. How bad was this? This was terrible. 6 music events, 3 of which are day-night cycles. 10 to 44 tracks per event. That's 20. Let's just call it 20 tracks on average times 3 intensity levels. That's 540 tracks, which means if we assume 5 minutes per track, that's 45 hours. 45 hours of literally nothing other than just recording this music. This is more than a week's worth of work, right? This is awful. You can't do this. This is ridiculous. So I told her, like, stop. Do not do this until I have a chance to look at it. Better way. FMOD Studio supports JavaScript automation. So anything you can do in the UI, you can do in JavaScript. Anything that they have the entire data model reflected in JavaScript. So I wrote a script, which I will show in a minute. It's less than 100 lines, which you make a copy of the event into an empty project and run the script. And it removes the loop region, creates a folder for these events, makes a clipboard copy of the event, for each track in the event, pastes a copy of the event into the folder, removes all but the given track, and then assigns the event to the master bank. Once it's done all of this, configures the project for 48K PCM uncompressed building, and then builds it. All of this with a click of a button. That's pretty cool. So, but that is only step 1, because now we have a bank file exported from FMOD Studio, which is intended for games to load and play back from there. So I had to write a second program, which is this exporter program. Again, less than 100 lines of code, or maybe just over, I don't remember. But it's this short program, which it loads the bank file and finds the names of all the events. And then for each event plus intensity level, because we have low, medium, and high intensity, it runs runs a mixer in what's called non-real-time WaveWriter mode. So FMOD has 3 modes that it can run, 3 broad categories of modes. The first one is just kind of normal. You load it, you tell it which driver to output to, whether it's with SAPI or whatever, direct sound or whatever you're outputting to. And then it just plays it to the speakers. Or you can give it in what's called a non-real-time mode, where if you can attach a callback and just run the mixer as fast as possible, and you just get the audio on a callback. Or you can run it in what's called non-real-time WaveWriter mode, where you tell it, instead of giving me a callback, just write the audio to a WAV file. And here's the file name. So I did that, And then we just play the event again as fast as possible. Just play the event, and it writes the file. And so let's see what this looks like. Here we go. So unfortunately, I don't have time to actually run the script in front of you. The script takes just like a few minutes to run. And so that, again, there's no time today to make that happen. But here's the event that we're starting with. This is our Goblin Lake music. And you see it's this big complex beast. So I ran the script, it created this folder. It then created all of these events, and each event has a single track with just the tempo markings and the instruments for that event. Here's the mid-intensity bed. Here's a flute track for low intensity. And you see it comes with all these, each track has its own set of effects and everything. And then it built all of this. The script to do all of this is short. Like I said, here it's less than 100 lines of code. And the program that I wrote is here, just over 100 lines of code, 160 lines of code. So what does this do? This ends up generating this build desktop master bank, 474 megabytes. Let's load, so this one. If I grab now my program that I wrote, my music track exporter, sits next to the master bank, and I just run this program. It finds all of my events and it's exporting them. And you can see as it's finding them, it's writing out these files, and each file is the contents of each track one at a time. And so that took, this track, I don't remember, it's 21, I think, tracks times 3. So we're talking 63 tracks times 5 minutes. We're talking a day's worth of work that I've just saved here, and it takes about 10-ish minutes to run the script and probably a minute to run this program. Seems like a worthwhile exchange to me. Anyway, so you can see here all of the events, and I want to let it run because it's really, ta-da, that's it. That is the entirety of all of these tracks. So that took me less than a day to write. Exporting the entirety of our music took about half a day for my sound designer. But like when I brought this to her and she realized that she didn't have to waste a week, it was just priceless. It was just like, yes, this is exactly what I live for with game audio programming, is giving these tools to sound designers and making their lives better. The other kind of meta task I want to talk about is low-end devices. So unfortunately, we have this big fancy music track, and the truth is that some devices just can't handle all of those tracks. There's just too much going on there, but we still want the fancy dynamic music going on. So how do we reconcile this where we physically can't do it, but we still want to do it? So what we do is we bake down the tracks to the stereo tracks and playback per platform. You don't have to do this for all the tracks. For Torchlight 3, we selected a few tracks in the events that had randomized elements that we wanted to keep. And so we just left those out of the stereo bake down. But how do we do this? How do we bake down our music track? Well, we know how to do that. We just copy the event to a new project, remove the loop region, remove the dynamic tracks, add it to the master bank, set it up as 48K PCM, and build. That's what that script that I wrote did, except it just had all this special other stuff. We're just not doing any of that. Now we have an event, and we could just run that event through the exact same program that we wrote before that exports the tracks, and it's going to go low, medium, high intensity. It's going to bake down the track. We're done. So unfortunately, I don't have a demo of that process running, but I do want to show what the result looks like. So I'm going to load here the Goblin Forest Night track, which will take a moment to load because it is massive. And we see here, every track is kind of normal, except we get down to the bottom and we have these 3 tracks, low perf low, low perf medium, and low perf high. I'm going to go ahead and set it up to high intensity, and we'll listen to it for just a moment. So that's the track. We saw some dynamic elements up here. that where I was picking a random variation of a particular element to play. But now, if I switch my platform from desktop high performance to a low performance entry, now we see that these three tracks light up and these ones turn off. Now when I play, we still get all of the fancy, the music exactly as it was before. We just don't have the dynamic elements in there. So this is kind of the breakdown that we do, where we want the dynamic randomized stuff, but then it's simple for the low performance tracks to play just a single streamed file. So I want to spend the last few minutes doing quick overviews of a couple of other things. Unfortunately, I'm running low on time, and I don't have time to do all of music. But we can talk about a couple other things. So first, if you want a good overview of dynamic interactive music, Volume 1 of Game Audio Programming Principles and Practices has a chapter by Aaron McLaren, who currently works at Epic Games. It was like their lead audio programmer on the Unreal Engine, has a chapter on interactive music systems for games. So that's worth checking out. Another thing is loading screens have an interesting and subtle challenges, because you're in this weird situation where you're not really in gameplay, but you still want to be playing the music, but you're trying to have the loading screen be up as short as possible. But because you're trying to load stuff off of disk, but at the same time you need to stream the music in chunks. So you're in this weird situation where you need to be scheduling your loads. You might need to be scheduling your loads. This is particularly bad if you're on a spinning media like Xbox 360, where you actually have to be able to run off of DVD. It's not so bad for SSD, where there's no seek times, but this is still something to be aware of, that if you have music playing during a loading screen, then your load will take longer because you have to be loading more off of disk, just naturally. The other thing to be aware of is that you got this weird situation where during level loads, you're not in the source location, but you're not at the destination yet either. So where are you? You know, it's a decision you have to make. If your loads are long enough, you might have a special music track that you played during the load. We did that for BioShock 2, and I worked on that. Or if you'd like Torchlight 3, our loads were short enough that we could just continue to play our existing track and then kind of crossfade the music track in when you kind of, behind the loading screen, had logically arrived at your new location, and then just kept that going until the loading screen went away. But again, loading screens, subtle challenges there. You might also want to do generative music. Now, I have never done a generative music system where you're actually composing music on the fly. Here are links to a couple of GDC Vault talks, which I believe are available without a subscription, to talking about Spore and No Man's Sky, where they talk about how they did a lot of this generative music. There's also chapters in volumes 2 and 3 by Charlie Huguenard, I think that's how you pronounce his name, about note-based music and improvisational music. So those are, again, worth checking out if you're interested in some of this generative music. You might also, if you're using a note-based music system, whether it's MIDI or something else, you might want to be doing synthesis if that applies to your genre. And that synthesis has a particular sound. If that works for your game, that's great. The canonical example here is Fract OSC, where they actually had a mixer, a kind of a, I forget, no, it's not a mixer, it's a sequencer running as part of their gameplay, where the music was, again, forefront. The music was not part of the background, it was part of the foreground. And so they had a synthesizer running, and they had this sequencer actually being a part, like that pulse of the sequence and of the music was a part of the gameplay. So orchestral recording is a whole thing. I don't have time to dive into it. The Vizori is just a really cool thing that we did, where we kind of recorded short chunks of music, of orchestral, just like sequences that can be mixed together as part of other tracks. And then if you are doing an orchestral recording for games, use a click track even if your orchestra is like, no, we don't want to, it's like use a click track because it will save you tons of time later on. And we did orchestral recording for Torchlight 3. Unfortunately, I wasn't able to go, but it seemed it was a really good experience, and I think the game is better for it. Last thing is synchronizing music and gameplay. Again, there's a chapter here on Game Audio Programming 2 by Colin Walder, who works at CD Projekt Red, where they actually talks about synchronizing the gameplay to the music, doing things like making sure that as the player's feet are hitting the ground on the beat, that as you're doing attacks, that they are hitting on the beat or on the measure, that those kinds of things are getting integrated. So that's a lot there. Music is kind of just one feature of game audio programming, and it's really deep. And I've had, unfortunately, I can't even go as deep as there is, right? And all these other things, each one is kind of equally deep. So there's a ton of knowledge and depth in game audio programming. So I hope that you've enjoyed this deep dive into music at this point. I have about 5-ish minutes for questions, which I will open up the Q&A panel now. And afterwards, I will be around in, I'll be on floor 4, and I will be in table 3. In fact, I'm just going to go there. So I'm in table 3 of floor 4 afterwards if you want to ask me more questions. So I'll go through, I see that there's some questions here, so I'll just go down in order that it's here. So what sort of personal projects would you recommend to get into game audio programming? The answer to that is I would actually start implementing features. I would learn the APIs for Wise and FMOD. I would start with FMOD. It's a little bit easier to get into and kind of has a lower level API than things like Wise, where it's just talking about tools. But start with that. And one thing you can do is you can find a game that has an audio engine that's very simple, that's open source, and just kind of slice out the audio engine and replace it. Like if you've got time and energy for that, then that's a good hook. It's a good place to do it. So off the top of my head, that's what I got. But yeah, just learning those APIs and working in that space. All right, so that one's answered live. Transitions from technical sound design to audio engine programming. What suggestions for someone on this path? For that, I would dive more into the. It's kind of a similar answer to the previous answer, where dive more into some of these engines. There's lots of into some of these APIs. Like learn the APIs and start to think about some of these features. So find resources. There's lots of GDC Vault talks which are available without a subscription, that you can see what kinds of features people are implementing. Obviously, my books are good resources for that, and see what kinds of things people are doing in that space, so that you can get an idea of what do game audio programmers do, so that because like the hooks are just the bare surface, right? And then start think about what kinds of tools, because if you're coming from a sound design background, think about the tools that you want, think about the things that you want to do in your work, and leave them like and implement them, like make them happen. So that's that one. All right. Also from Colin, when you're dealing with these massive orchestral mixes in FMOD, how are you handling the voice demands? So so actually I kind of answered that partially with the low end platforms. We did have to collapse those tracks down. But for the high end platforms, usually that's not a problem. The one place where it actually did become a problem for us was where some of these events that ended up having a parameter, or an effect on them that was just too computationally expensive. And in particular, it was a time invariant pitch shift, which basically don't let any sound designers use that in a real-time game, because they're cool. you can, but you have to be very, very careful about them because as soon as you have one, you've basically saturated your mix on a lot of platforms. So that was one of the challenge. That was one of the things there. And my own experience, to what extent can technical changes in game music be automatically tested? And follow up, is it worth investing in automatic end-to-end testing, especially when a project is very large and multiple teams people are working on the music? It's a great question. So you can do automated testing, right? Like you can just verify that the things are working the way that you want them to. And that is step one. It's just like, you can write an automated test. Like if this has some limits, then those limits are respected. And then you can also do some statistical analysis. So we have set up on Torchlight 3 where we can actually upload statistics, upload information about what's going on in the game to a stats server. And you can kind of tell what's going on in the game, and then through some graphing, so by looking at this massive data and graphing what's happening. So you could upload information that we didn't end up doing that because we kind of found a way to do it without it. But all this, there's definitely room for automated testing in this space. Somebody stop me if I'm running low on time, or if I'm running out of time, but I'm just going to keep going until somebody says to stop. From Elizabeth.
You still have some time, Guy.
Okay, cool.
Good.
Did you develop skills? Did you experience something particular which you find highly important for working in different fields of sound design during the work in game audio programming? So I've never worked in sound design, but I'll tell you something that was immensely valuable for me is my first game audio programming gig. I was working on Hellgate London. And I didn't my sound designer said, do it this way. And I did not understand why. And so the sound designers, there were, I think, 2 of them at the time, they said, okay, stop your work, come upstairs with us. And I went and I sat down for a day, so even less. It was probably like 2 or 3 hours with the sound designers, and I watched them and they explained to me, this is what this is how it works, this is why it is the way it is, this is what this is how it works, this is why it is the way it is. I had this great dialogue back and forth, and getting that understanding of what a sound designer does and how they work was hugely valuable as an audio programmer. So I'm not coming from that background, but like understanding it is invaluable because, again, the tools that I'm making need to speak to the sound designers. A lot of what you're doing is kind of taking the tools that they have offline and making them available for online. Do you do anything with procedurally generated music? Unfortunately not. It'd be a cool project, but I have not actually worked on a project with procedurally generated music. If you are interested in it, then these 2 talks from GDC are the place to go. These are the places that I have found with people talking about that. So unfortunately, I don't have much more to say about generative music just because I've never done it. Special recommendations for spatial game audio, recommendations about 3D ambisonics, 3D objects. All right, so again, I've never done any ambisonics or VR stuff. So this is coming from a little bit of an outsider perspective. But so for the basics of 3D sound, your mix is just going to work, right? Like if you use FMOD, Wise, ADX2, if you use any of these middlewares, your mix is just there. And it is, if you place a sound in 3D, you update its position, you update the listener position and orientation and all these other things. As long as you're updating the audio engine state to reflect the game state, then your panning and attenuation will work correctly. Asterisk. Some games require you to handle attenuation differently. If you're doing a third-person camera, there is a procedure outlined in Game Audio Programming, Volume 1. A little bit of math, vector math you have to do to get the attenuation and the panning to work correctly. The newest version of FMOD, version I think 2.01, actually has implemented that if you use the event API. But if you, yeah, so anyway, so there's some panning attenuation stuff. In terms of ambisonics, again, a lot of that is handled for you through a real-time mixer that you can, it's a real-time panner, an object panner, it's called an FMOD. Each system, each middleware has its own nomenclature for it. But again, beyond that, I don't have a whole lot other than to observe that with object panners and ambisonics, you're kind of taking the sound and applying a filter to it to get it to ambisonic, and that can conflict. So if you're with some of the other effects that you might be applying, like if you're applying a high or low pass filter, that can actually affect the ambisonics of a sound in ways that I don't understand deeper than that statement. So that unfortunately I don't have anything around deeper than that, but that's what I got.